Starting with the name of Almighty Allah Ta'ala. Yesterday, we learned electrolysis of molten ionic compound like molten lead chloride or ionic compound that is sodium chloride. In case of molten ionic compound, there are only two type of ions. One is cation and another one is anion. Like in case of sodium chloride, one was Na positive and the next one was Cl negative. So Cl negative was discharged, was oxidized at one electrode, that is positive electrode, the anode, right? And we got Cl2 in gaseous state, right? Same is the case with sodium, gained electron at negatively charged electrode, that is cathode, and sodium reduced to sodium. Now, in simple words, in molten ionic compound, we have simple split it. We have divided or dissociated or and distributed or broken down ionic compound into its respective elements. We have broken down NaCl into sodium and chlorine gas, right? Then we studied the electrolysis of aqueous solution, right? Aqueous solution of ionic compounds. We studied two cases. Aqueous solution of ionic compound can be very concentrated. We took example of brine, that is concentrated solution of NaCl. And I also told you about the difference between concentrated solution and dilute solution. Similarly, the next case is that of dilute sodium chloride solution, right? We also took the dilute solution of NaCl. Sorry about that. NaCl, right? Solution of NaCl in dilute case. Now we studied, sorry about that. Chloride ions are discharged at anode and we got chlorine gas. Okay, now today we are going to electrolyze the dilute sodium chloride. We will be performing the electrolysis of dilute ionic compound. Now remember, the product for both, although the compound is same, this is the concentrated solution, whereas this one is the dilute solution. The compound is same, but the product will be different. In this case, hydrogen gas will be produced and oxygen gas will be produced. Why? We have discussed this one example in our previous class. We will be doing this one today. I will be explaining you that why oxygen gas will be released instead of chlorine gas. Now let me clear this in detail. Again, I am going to take a beaker, a simple container, in which I will be pouring the dilute solution of NaCl. This is the dilute solution of NaCl, right? Now, as explained yesterday, we will be taking two electrodes made up of either platinum or graphite, that is carbon. This one will be connected to the negative terminal of the battery, whereas this one will be connected to the positive terminal of the battery. This will be called as cathode, and the positive electrode that is connected to the positive terminal of battery will be called as anode. Now, as we know that NaCl will be present in the solution in the form of Na positive and negative. Same is the case with water. We know water molecule hydrolyze to form H positive and OH negative. So water molecules will be present in the form of H positive and OH negative, right? Whenever we will on the battery or we will pass the current from the source, from the battery. Is it clear? Now this is a dilute solution. So the number of NaCl, the NaCl particles, the Na positive and Cl negative will be lesser, and the particles of water will be more, will be greater. The concentration of NaCl will be lesser, right? Now, what will happen? Remember, towards negatively charged electrode, positively charged ions will be attracted. Of course, according to the reactivity series, that is, please stop calling me a cute zebra. I love hot coffee, sip in gold, right? Now, hydrogen and sodium. This one is, I also told you yesterday, more reactive, which means that it will have more ability to lose electrons, which means that, in other words, less ability to reduce or gain electrons. Same is the case with this one is less reactive, which means it has lesser ability to lose electrons, but more ability to gain electrons, more ability to reduce, right? Now, instead of sodium, as we know that the particles of hydrogens are much more greater per unit volume of the solution as compared to sodium. So of course, the hydrogen will gain electrons at cathode and will be reduced to hydrogen gas. And we will see the bubbles of hydrogen gas releasing at cathodic side. I hope you are getting my point. Hydrogen gas will be released. How will
Yes,
we
sir.
detect hydrogen gas? We will be doing that later in order to confirm the presence of hydrogen gas. Now, if we talk about the negatively charged chlorine ion will be attracted towards the positively charged anode. Also, OH negative ions will be attracted towards the positively charged anode, right? Now remember, as we know that the number of OH hydroxide ions are much more greater, much more greater as compared to number of Cl negative, the chloride ions. So of course, one reason is that the OH negative will be oxidized at anode, and as a result, oxygen gas will be formed, right? And also, when I've also told you yesterday in our class that if there is comparison between halogens like chloride ion or bromide ion or iodide ion, and comparison between OH, right? So OH ion will discharged earlier, will discharged first, right? Into oxygen. If dilute halide solution is being electrolyzed, oxygen is produced, oxygen is formed. Is it clear? Because the number of particles hydroxide ion are greater as compared to, right? But for concentrated solution, for example, in case of barium chloride, the chloride ion will be discharged more readily, right? So then hydroxide ion. Whereas in dilute solution, OH ion will be discharged. Now, simple water plus oxygen gas, but this is not still balanced. 2, yes, and 4, okay, right? So 2 water molecules are released, oxygen gas is released, and 4 electrons are released. Now look at here. In case of Cl negative, only 1 electron will be released, whereas in case of OH negative, 4 electrons will be released, and as a result, 1 water molecule will be formed. 2 water molecules will be formed, and 1 oxygen molecule will be formed, right? Which is more stable, more easily to release. And also, 4 electrons will be formed, and 4 electrons will be going towards the negatively charged cathode, the battery, and these electrons will be gained by hydrogen, the protons, and the protons will be reduced into hydrogen gas. So, in summary, if I want to summarize it, in case of dilute solution, as there are more OH negative ions, so OH negative ions will prefer to oxidize, to discharge at anode to form oxygen gas and 4 electrons and 2 water molecules instead of chloride ion. Whereas in case of positively charged ions, as the number of H positive are much more greater, and also the ability of H positive to gain electron is much more greater as compared to sodium. So that's why the protons will preferably reduced at cathode. Understood? Now look at this one. Now, how will we detect the presence of gases? In
से
case
जो मैं
now you will have to bring the match closer, the glowing splint closer to the side where oxygen gas is releasing, and the flame will increase, the strength of the flame will increase. It increases basically the fire. In excess supply of oxygen, the wood will burn more quickly, more readily, more easily. Whereas in limited supply of oxygen, the wood will not burn easily, right? Similarly, in order to detect the
सर आप ये दोबारा से एक्सप्लेन कर सकते हैं ऑक्सीजन टेस्ट
remember, oxygen helps in burning. In other words, helps in increasing the flame size. You can say that flame size, right? You will bring the glowing matchstick closer to the side of unit cell in which oxygen gas is continuously releasing. If you feel that the size of flame is increasing, then it means it is oxygen. This is the presence, this is the confirmation of oxygen, right? And if it is not,
ओके
might be another gas. Yes. Similarly, in case of chlorine, in order to detect the presence of chlorine, you will have to bring the damp litmus paper closer the outlet of chlorine gas, right? It will first convert into red and then will convert into white, which detects the presence of chlorine. Similarly, in order to detect the presence of hydrogen gas, if pop sound squeaky sound is produced after you bring the glowing match, the glowing flame closer to the hydrogen gas, then it must be hydrogen, right? You can say that if gas produced at cathode burns with a pop sound, with a pop, right? When a sample is lit with a lightened splint, then the gas is hydrogen. Understood? Yes. Is it clear, dear students?
Yes, sir.
One is H positive. In other words, H2SO4 will dissociate